Hi, this is Laura Haran, and I'm going to be walking you through my InfoVis portfolio for my infographic on bike counter data. So first, let's talk about visual potential. Numeric potential is exploited several times throughout my infographic, which isn't very surprising. The key graphs are this display on seasonal trends, which displays the monthly average daily bike traffic on 2 trails. In addition to this column chart that shows how many bikers were on the trails, we also have a line graph which demonstrates daily bike crossings on the Fremont Bridge, counting the number of silent cyclists per month, or per day really, but it's mapped out per month. Finally, we have 2 sets of heat maps that map out daily traffic per hour, so how many bikes are going in each direction, both during the weekday and the weekend. Location potential is exploited in the bike counter program as expanding display, which shows where bike counters are located on the map of Seattle. This also exploits time, since it's showing like how it's changed over 3 years, as well as numeric because it identifies exactly how many bike counters there are quantified right there. The appearance is potential, which is really fun. I have 2 displays that sort of identify that. The first one is up here by my title, which is a it's an abstracted version of what actually goes on when you're counting bike data. So we have these little cyclists on a trail, they're going in both directions. And then here we have a abstracted bike counter. So the idea is like, as the spiker is crossing, the number is turning, and hopefully that implies to my viewers that, hey, that's how this bike counter data is collected. It's based on counting how many bikes are on a trail. Additionally, I also used a bike wheel. Again, it's abstracted. It's only half of a bike wheel in my relationship display. This also demonstrates relationship potential because it's an abstracted hub-spoke diagram. So basically it's saying that these entities are people who use bike counter data. So it's the relationships of them using this data. So for example, city planners might use bike counter data to advocate for more bike trails. Finally, time potential. We've talked about it with, 4 of the displays actually. Um, Bike counter data is inherently very time oriented. So all of these are showing changes over time. For example, this one is showing like how bike traffic varies on a day-to-day basis over the course of a year, how it varies on a monthly basis, how it varies on an hourly basis, both for weekday and weekends. But time is the main x-axis. All right, next let's talk about encoding, which is talking about when visual attributes equal a data attribute. So for example, in several of my displays, distance on the x-axis, so going across here, or across here, or across here, represents the passage of time, whereas height on the y-axis for this cyclist one, as well as over here, represents like the number of bikers. Those are 2 examples of encoding. Another example of encoding is when here I use the color orange to represent the Fremont Bridge and the color blue to represent the Elliott Bay Trail. Over here, orange is again used to talk about the Fremont Bridge, but up here it's a different scheme, in part because I wanted to use saturation, sort of like a gradient saturation to demonstrate the number of bikers used because it's a heat map, and so like the encoding is more related to the color saturation. I thought about doing both blue and orange maybe for the different trails. However, this shade of orange, when it's light in several tints to a very, desaturated orange, it actually really nearly blends in with the background. So I decided to just keep it blue. But those are a couple examples of encoding in my diagram. I like that there's a variety of encoding types used within the displays because I think it adds visual interest. I suppose I could have stacked little bikes, which could represent like a number of bikes, for example, for the monthly average daily bike traffic. So 3 bikes might represent 75, whereas 6 bikes might represent 150. Um, but I felt that these displays are easier to gauge, so people are really interested in seeing like how many there are. They can sort of follow their eye. Whereas if there's little bikes, you have to think, okay, well, how much does each bike represent, and how many bikes do I have? This might be a little bit easier for them. Moving on, let's switch gears and talk about color. So to refresh your memory, here is a picture of my color model. It utilizes beige for background, white for structural elements, as well as some black, orange and blue for a lot of their illustrations. Statistics are marked in blue, years are marked in black. Origin is used as an accent color, and I did depart from this a little bit, but the colors remain the same. So here are the colors that I use in my infographic. I have a beige background. I use black primarily for text, as well as years, annotations, and labels. White is used in one of my appearances displays, but also to add structure through lines. Orange is used both as an encoding as well as in some displays in my graph. And then blue is also used, and I also sort of broke this out. This is something that they didn't do in my original model, but I made some tints of the blue to use for encoding in my heat maps. So as I briefly mentioned, again, that gradient of blue tints is used as an encoding measure here in my heat maps. Orange and blue are used here in this graph to demonstrate the difference between the Fremont Bridge data and the Elliott Bay Trail, so they represent the different trails. Is color used for trigger associations in my infographic? I wouldn't say that it is. I thought about it as I was going through the process of building this infographic, and no colors really jumped out as me as bike. Like certain things, it's like, oh yeah, I could use colors to represent different countries or different sports teams, but there didn't really seem to be any that were appropriate for my data. Thinking about the tone that the color set, I like this color model that I used for my final infographic because the neutral beige background, white accents, and black text lend an air of professionalism. It's a really simple background. It's easy on the eyes, which is something that wasn't the case with my original color template or color model. And also the bright blues and oranges really liven up the infographic and match the fun nature of the topic. One example of where color is used to highlight, I added orange circles here for the quantification of the number of bike counters, and also to differentiate it from the year above. Additionally, this is something that I added. I made this circle here blue to sort of separate the bike counter data from the entities that use it to sort of like make my relationship to display a little bit more clear. This infographic uses a complementary color model with the primary colors being blue and orange. And primary meaning, the main colors, not primary colors, because orange isn't a primary color. Additional color used are neutral, beige, black, and white, which don't really interfere with the complementary color model. Next we can move on to text. So this is my text model infographic, the one that I based my own text model off of. It was also the original color model of my infographic. I was really attracted to the bright colors and looking at the text. Like I was interested in using a slab serif in mine. And so I went with it for text as well. And while I changed my color model, I decided to keep with this one. I really like the slab serif for the titles that they use, as well as the sans serif for annotations and copy. I think it lends, like the slab serif is like more interesting than like a normal serif font, and the sans serif has like a clear and professional and modern tone to it. Before I show you what I did with mine, one thing I wanted to point out is that there are a lot of large slab serif numbers that are called out throughout the infographic. This is something that I didn't carry over into my current infographic because my emphasis on the data was I was more interested in sort of showing like general trends than highlighting specific numbers. So like, I didn't really feel that calling out like there's 70% more traffic on the Fremont Bridge in July than the Olympic Trail, for example, wasn't really a goal of mine. So with that in mind, um, we can move on and look at sort of the hierarchy of text that I used. There was more textual hierarchy for mine based on like the layout model. Like I definitely wanted to have both like a main title but also section titles, and then also titles for my graphs to give those context, um, labels for my graph, copy and annotations. With my relationship display, I wanted those to sort of stand out, so I created their own like type size, as well as within the annotations, or not the annotations, sort of like the copy underneath my relationship display. I wanted to make sure that the different sections were identifiable, so I again took from the Rockwell theme to create that. So with that in mind, you can see that I'm very consistent in using the same size font of sans serif. I used Helvetica Neue for my annotations, my copy, and stuff like that. I use a slightly smaller size for my chart labels. And Rockwell in various sizes is used for different titles. So sort of like in HTML, if I want to have like a scheme of headers, like they each have their own. With the exception of my numbers underneath the graphs, I didn't really use precision labels. However, I mainly associated information labels associated with what they're labeling by proximity. So having stuff like nearby the graphs that they are representing, for example, with this heat map. I also occasionally use lines or brackets to point out things like within a chart that might be interesting to people. Lines are also used here with the maps to sort of affiliate what this label is with the point on the map. All right, moving on to visual hierarchy, which is a little bit tough to talk about after spending so much time with my infographic. It's hard to look at it with new eyes. But generally speaking, when I first look at it, it's clear to me that there are two sections, in part because there's a divider here and also there's white space, probably like the most consistent use of white space in the areas right down the center. My original infographic that I used for my layout was this honeybee model, which I think did a little bit better job in denotating the different sections. So obviously there are the two, right? Like there's this main section with the title, pulls your eye down through this, and the idea is you move to the right into this half section, and then up, and then over again. Sort of like the golden ratio type of display. There's a lot more white space here, and they also, I think the lines might be a little bit more bold, or not bold, but they're striking in a way that isn't really apparent in my infographic. I noticed I didn't use probably enough white space to make these sections more distinct from one another. However, what I lack in white space, I think I make up for in terms of the different colors within my visual hierarchy. So like the title is the biggest text on the page, and there's also this very eye-catching squiggle trail appearance display, which I think would bring your eye to the top here. Next, I think you'd probably be drawn down to this very visually appealing, energetic line chart, possibly over to like this very large wheel display, and then up through like this sort of like blue-orange pattern. since we're on the topic of variety in terms of all the colors used and the different displays and how that sort of draws the eye through it,